All right. Part F of Module 4, Merge Sort. In this part, we will learn another sorting algorithm, merge sort. Part F.1, Introduction to Merge Sort. First, let's look at a simple problem. So that is our problem number 12, merge two sorted arrays. Very basic, but very useful problem. Given two ordered arrays, how to merge them to get an ordered larger array containing the elements from those two ordered arrays. So that kind of simple, basic problem, why we need to do this one. So that's the question, right? The motivation. Here, let me give you a simple reason. Let's think about this question. How to sort a huge array. The array size is extremely big. How big it is, so let me describe it this way. You cannot get all the elements loaded into memory at the same time because the size is too big. You have to load the elements, part of the array. So every time you can only load a sub-array. You cannot load the whole array that big. When you have that kind of situation, how do you solve that problem? Right? So you need to think about those special situations. Here, a simple idea to solve questions like that. Suppose we have a huge array here. We cannot put it into the main memory at the same time. One way we can do, divide and conquer, right? Divide and conquer. So we divide this huge array into many pieces. Each piece we can load it into array, right? Each piece we can load it into the main memory. And after we load it, we can get it sorted. So using, one of the sorting algorithms. After that, then we need the solution of this problem. We need to merge all these ordered subarrays. So we can use parallel computing to do that if we have a lot of computing facilities. All right. So here you can see this is the situation or the background for our problem number 12 we need to solve. All right? Next, let's work on this problem, how to merge two sorted arrays. Here, when we work on it, we want to use our experience. We just learn from insertion sort, right? Insertion sort, we just learn it. Let us try to use that experience here. All right. We want to take advantage of structured data. What do you mean structured data? Two sorted arrays. We can treat that as structured data. But the question is, how do we take advantage of the structured data? Here, let's look at the sorting algorithms we have learned at this point. So which one is likely to be useful for our current situation? Here, we want to get some sorting algorithm that makes use of, all right, do not use any sort that does not make use of any order information. Because for some sorting algorithm, the order information is not important. If your data is sorted, ordered, or unordered, you get the same result. You get same number of comparisons. We have many sorting algorithms like that. For example, selection sort, the order doesn't matter. Bubble sort, the order doesn't matter. But our insertion sort is special. The order matters. If your data is ordered, then insertion sort is the best. So that means we can borrow some idea from the insertion sort. Insertion sort, yeah, useful for this merge sort. Yeah. All right. Here, let us look at the relationship between the insertion step and this merge step. Here, we need to do that merge step, not insertion step. They're different, but they are related. So we want to, look at the difference. Yeah. All right. So here, the reason we want to take a different view, because that will give us new idea. Yeah. So we can, improve our sorting algorithm a little bit. Yeah. Here, let's look at a typical insertion situation. This is a typical insertion situation, right? Insert this V element into an ordered array. Now let us take this view. This V, we can treat it as a one-element array, right? That is still another array, one-element array. And this element, one-element array, we can also treat it as a sorted array. So here you can see the insertion step becomes a special merge step. Merge two ordered arrays. See, that's the relationship. That's the connection. Yeah. So with that kind of connection, so then we can, when we do the merge, we can borrow some idea from the insertion step or similar idea from the insertion step. Okay, yeah. All right, so now the new view. We want to do the new interpretation and a new view. Yeah. Two sorted arrays are combined to get a new sorted array. Yeah. We treat that as the merge step. That's the merge step. Okay. Merge two sorted arrays for a new sorted array. Okay, yeah. So here, this merge view is important. Okay, yeah. So we take this new view, the merge view. Yeah. For the data size, when we do the merge, for the insertion case, data size, one array, the size is k, the other one special, one element, the size is 1. Yeah. But for this case, the sizes of two subarrays not balanced. Not balanced. So that will usually cause the poor worst case efficiency. Yeah. Unbalanced data usually causes poor worst case problem. So we want to fix it. We want to avoid poor worst case problem. Okay? Yeah. Insertion sort has the poor worst case efficiency, right? So we don't like that. Okay? We want to reduce the poor worst case efficiency. How to fix it? The idea is pretty straightforward. Yeah. We try to make our data balanced. Yeah. So that's the main idea we want to use to improve the efficiency. Yeah. Yeah. Here we call it balancing principle. balancing principle. When we have options to distribute, arrange our data, we make the most balanced distribution. We make the most balanced arrangement. In that case, we can avoid poor worst case. So that's the key idea of this new method. All right. Try to make two subarrays of equal size. So because we have options, when we split original array into two subarrays, we have many different ways to do the split, right? We have options to arrange two subarrays. When we have that freedom to do the arrangement, we will do the most balanced split. So that's the essence of this method. Okay. We will do that part in our part F.2. So we will work on that. The explicit, the merge operation. So we finish our introduction step right here.